Let us understand the hydration of cement. After watching the video in the module, you have far better clarity about the hydration of cement. But it is very important to understand the reaction to much greater extent. Once you gain the thorough knowledge of hydration of cement and its product, it will be very simple for you to understand the subsequent module and expertise in the concepts of concrete technology. Now first us understand what is this hydration of cement. It's very simple. Water is added to a cement and that is the hydration of cement. So just adding a water to a cement is a hydration of a cement. Now let us understand what happens when a water is added to a cement. The product formed in reaction has cementing or adhesive properties. So when water is added to the cement, there are certain chemical reactions take place. Now we should try to question what are these chemical reactions and in what process or what steps it happens. Now the reaction of cement with water is exothermic, that is the heat is released during the process. Now let us try to break this concept into parts and understand it into the depth. Now the first thing is addition of water in a cement. So as soon as water is added to the cement, a rapid heat evolution due to the reaction take place. Reaction of aluminates and sulfates. So when we add a water in a cement, there is an immediate reaction between the aluminate and sulfate. But aluminate reacts so quickly and harden the cement in the fraction of a minute. So this point is to be noted that as soon as we add the water to the cement, the aluminate in the cement start reacting and it sets quickly within the fraction of second. So we must be adding something to retard this, because at side we have seen that when we add a water to cement, we do have a sufficient time to carry it, place it into the required location. So that means there must be something that we need to add in cement to prevent this immediate reaction. Now what is that chemical? To prevent this flash setting, gypsum is added in the cement. So when gypsum is added in the cement, it immediately prevents the initial reaction of aluminate. So this immediate reaction of aluminates prevented by this chemical, which is gypsum. Already in the manufacturing process we have came to a point where we know that gypsum is added during the manufacturing process, and now through this we understand that why it is added. Now what happens after that? So the next step, next heat is evolved due to the reaction of tricalcium silicate. So after aluminate, the next chemical which react is the tricalcium silicate, and dicalcium silicate is the last chemical. So we must understand this, that first aluminates react, after that tricalcium silicate react, and the dicalcium silicate is the last chemical which react with water. When tricalcium silicate and dicalcium silicate react with water, calcium silicate hydrate CSH gel and calcium hydroxide are formed. This particular statement is very important because this forms the basis of entire concrete technology. If you understand this reaction, then your subsequent modules will be very easy for you to grab the concept. So when we say concrete, we mainly talk about the cement, which is this binding material. When we talk about the cement, it is this tricalcium silicate and dicalcium silicate which provide the cementitious strength to this material. And why they provide cementitious strength? Because they form calcium silicate hydrate gel. So this is CSH gel. This gel is responsible for the binding of aggregates in the concrete. CSH gel is the major chemical which forms the binding strength between the aggregates and make the material so strong. So the entire concrete technology revolves around the CSH gel. CSH gel is the only chemical. However, as a byproduct, calcium hydroxide is also formed, but it does not contribute to the strength. It's just a byproduct. Now, CSH gel is the most important product as it gives strength and adhesive property to cement. It makes up to 60% volume of a solid hydrated cement paste. So now we understand that when we use the raw material and use the dry process and wet process, we obtain four chemicals, that is dicalcium silicate, tricalcium silicate, tricalcium aluminate and tetracalcium aluminoferrate. And then when we add water, first aluminate react, then tricalcium silicate react, and in the last dicalcium silicate react. Now once this water cement reaction take place, then two products are formed. One is the CSH gel, which is entirely responsible for the strength, and then is the hydroxide, calcium hydroxide, which is a byproduct and does not contribute to the strength. Now let us understand how this dicalcium silicate and tricalcium silicate make all the difference. Tricalcium silicate reacts before the dicalcium silicate. As we have already studied that the dicalcium silicate is the last chemical. Now what happens? They react to form CSH gel. So both, first it's the tricalcium silicate which react and then the dicalcium silicate reacts and both forms the CSH gel. But tricalcium silicate produces a comparatively lesser quantity of calcium silicate hydrate and more quantity of calcium hydroxide than dicalcium silicate, which produces more quantity of CSH gel and less quantity of calcium hydroxide. So it's very important to understand these three sentences here. Now we know that both tricalcium silicate and dicalcium silicate reacts to form CSH gel, and we know that CSH gel is responsible for the strength. So basically, chemical which form the more CSH gel will give more strength to the cement. So the cement which have more C2S, dicalcium silicate, will have more strength than the cement which have more C3S. The reason is very simple. The reason is the more CSH gel, the more strength will be there in cement, and we obtain the more CSH gel in dicalcium silicate, and in tricalcium silicate we obtain the less CSH gel. Do you know, calcium hydroxide does not give any strength to the cement, and hence it's an undesirable product which also reduces the strength. So this statement is also very important, that in tricalcium silicate lesser quantity of CSH gel is there and more quantity of CaOH gel, that is calcium hydroxide, and this calcium hydroxide is undesirable product which reduce the strength. So now we can make this conclusion: cement having more dicalcium silicate will be more stronger, cement having more tricalcium silicate will be less stronger. Now let us ask some question to ourselves based on these reactions which we have just studied. If aluminate and sulfate react instantly with water, then how gypsum prevent it? How gypsum prevent the immediate reaction between the aluminate and water? How it behaves as a retarder? We need to understand this. Now what if C2H quantity is increased in the cement? Dicalcium silicate if increased means tricalcium silicate is reduced, and we already know that increasing a dicalcium silicate means more CSH gel. More CSH gel means more strength. Why calcium hydroxide reduces the durability? Now we know that calcium hydroxide is an undesirable product, but we need to understand why. How setting time of cement or strength gaining can be controlled. Now we know that different chemicals react differently with water. So increasing one chemical will enhance one property, while increasing another chemical will enhance another property. That we need to understand. This entire question will be automatically answered by you once your few more modules will be complete. Along with this, thousands of mysteries of cement will unlocked. Till then, keep such questions in mind, as it will make your grip on the concept further stronger. The more question you ask, more clarity you will get when you find the answer. Now let us understand this chemicals. Calcium hydroxide. The calcium hydroxide also react with sulfates present in soil or water to form calcium sulfate, which further react with calcium trialuminate and causes deterioration of concrete. This is known as the sulfate attack. Now in our quest to find the reason why calcium hydroxide is undesirable, here is the answer. Chemical hydroxide is a byproduct of cement water reaction. Now this calcium hydroxide reacts with the sulfate in the soil and forms some chemical, which is calcium sulfates. When calcium sulfates reacts with the tricalcium aluminate in the cement, and due to this reaction the strength of the cement decreases, and this is known as the sulfate attack. So due to the sulfate attack, calcium hydroxide is undesirable. So how do we prevent calcium sulfate attack? If the calcium hydroxide quantity in the cement will be reduced, then the chances of formation of calcium sulfate will reduce, and hence the tricalcium aluminate will not be able to react and deteriorate the concrete. Now the question arises, how do we decrease the quantity of calcium hydroxide? Now let us understand. The use of blending materials such as fly ash, silica fumes and such other pozzolanic material react with undesirable calcium hydroxide to convert it into CSH gel. Hence further increase the strength of concrete and preventing sulfate attack also. So this is the mystery which was solved by the Roman, as we studied in the history of cement, that they used to add volcanic ash. So when they used to add volcanic ash, this pozzolanic material used to react with the calcium hydroxide. Now calcium hydroxide is very undesirable because it causes sulfate attack. So once we able to remove this calcium hydroxide from the cement, we are able to generate more strength. The reason being, the undesirable calcium hydroxide quantity is reduced. And also this point to be noted, that when calcium hydroxide reacts with fly ash, then it forms the CSH gel, which is a desirable byproduct. So calcium hydroxide, first it is removed and second it is converted into CSH gel. So the quantity of CSH gel is increased, further adding into the strength of the cement. So this is a very great way in which the undesirable product converted into the desirable product. And now we know that calcium hydroxide is undesirable because it causes the sulfate attack. And what is sulfate attack? sulfate attack is nothing but the reaction of calcium hydroxide with the with the sulfate in the soil to form calcium sulfate, which react with the tricalcium aluminate to form a product which is not good for the concrete strength. Now let us understand calcium aluminate hydrates. The reaction of tricalcium aluminate with water is very fast, and this may lead to the flash set. To prevent this flash set, gypsum is added at the time of grinding of cement clinker. This fact we already knew. The hydrated aluminates do not contribute anything to the strength of the concrete. On the other hand, their presence is harmful for the concrete, particularly where concrete is likely to be attacked by sulfates. So the presence of tricalcium aluminate is actually not very good for the concrete or the cement because it promotes the sulfate attack. So when removing of this calcium hydroxide also help us to kill the opportunity for C3A to do the sulfate attack. But still the gypsum is very much required in the cement because it's prevent the flash setting or the quick setting of the cement. So in further module, which will be third module, we will understand the types of cement, and if you able to grip this chemical reaction, that module will be a very easy task for you. Till then, keep learning, keep growing.